A rational expression is a rational number with variables. So a rational number is something that can be written as a fraction. The only thing that you cannot have in a rational expression is a variable as the exponent, like this, or a variable underneath a radical, like this. So this is okay, this is rational, this is not rational, this is okay, and this is not rational. It doesn't matter if it's in the numerator or denominator, as long as you don't have an exponent that's a variable or a radicand that is a variable. When you have fractions, the only thing that isn't allowed is a 0 in the denominator. So when you have a 0 in the denominator, it is undefined. Non-permissible values are values that make an expression undefined. So when it makes the denominator 0. So for this one, x cannot be 0, or else it'll be undefined. So your non-permissible value is 0. For this one, it doesn't matter because it's in the numerator, so there's none, so x could be any number. Because we're adding, it's still over 1, so x is any number. And when you divide by x, x cannot equal 0. When you're finding your non-permissible values, first you factor your denominator, and then you find out what the values are. So for this one, our denominator is x squared minus 9. This is a difference of squares, so we can factor it to be x plus 3 and x minus 3. So that means that either x plus 3 equals 0 or x minus 3 equals 0. If we subtract 3, x can either be negative 3 or x can either be positive 3. So these are our non-permissible values, so we know that they cannot equal. Otherwise, the denominator will be 0. And if you plugged them in to this equation, it would make it 0. Same with the next one. We want to factor our denominator, so blank plus blank equals negative 8, and blank times blank equals positive 16. So we have negative 4 and negative 4 are our two numbers. And because a is 1, it'll factor out to be x minus 4, x minus 4. So x minus 4 can equal 0. So x equals 4 is our non-permissible value. I'm pausing it. Oh. For the last one, this is our denominator, so x squared plus 1. There's no possible way to make that 0 because we know that x squared will never be a negative 1. So for this one, we have no non-permissible values, so x can be an element of the real numbers, any number at all. For this one, we're writing equivalent fractions. So when we write equivalent fractions, you can either divide or multiply by the same number on the top or the bottom. So if we wanted to simplify this, we would divide, and we could divide by 6. And we know that it could be equal to 2 over 3. And this fraction is the same as this fraction. We can also make it bigger. If we times both the top and the bottom by 2, we would get 24 over 36. And we know that this fraction is equal to this fraction and this fraction because they're all equivalent fractions. You can do the same thing with variables. So if we wanted to take out a common factor, we could take out a 4 from both of them and an x from both of them. So the top would turn into 5y, and the bottom would turn into 2x. So this fraction is the same as this fraction. We could also make it bigger. If we wanted to multiply by anything, say we wanted to multiply by y, this would turn into 20xy squared, and this would turn into 8x squared y. Let's put a little circle so we know that these are multiplying. So this fraction is equal to this fraction, it's equal to this fraction, they're all equivalent. If we wanted to write an equivalent fraction for this one, first we need to determine what our non-permissible values are. So on the bottom, x cannot equal positive 1, or else it will be 0. Now if we wanted to simplify, we could cancel out both of these terms, and we'd be left with x plus 5 over 2, when x does not equal 1. Now this is equivalent to our original equation, and that is why you need to keep your non-permissible value as x cannot equal 1. If we wanted to make it bigger, we can multiply by anything we want. If we wanted to multiply it by x plus 2, we already know x cannot equal 1, but also now if we add this, it cannot equal negative 2. So this rational, x plus 5, x minus 1, x plus 2 over 2, x minus 1, x plus 2, when x cannot equal 1 or negative 2. This is the same as this. It's the same as this. They're all equivalent rational expressions. When we simplify a rational expression, our first step is to determine our non-permissible values. So a cannot equal 0 and b cannot equal 0. From here we're going to simplify by a common denominator. So for the coefficients, we can take out a 5, and we can also take out 1a and 2 b's. So it's the most common, the greatest common factor, GCF. Remember to look for it. So we will be left with, on the top, negative 5, a squared. The b's will cancel, c, over 35 divided by 5 is 7. The a's will cancel, and you'll be left with b3. When a cannot equal 0, b cannot equal 0. You have to always put in your non-permissible values. It's part of your answer. For the next example, our non-permissible value will be x cannot equal 0. Now we can take out a common term of 3. And the only reason we can, or 3x, sorry, is because there's a 3x in this, a 3x in this, and a 3x in this. When you have a binomial, you have to be able to take out the common term from every single term in the expression. So we're going to divide by 3x on the top and the bottom. So we should be left with 2x plus 4 over 1. And because these are both divisible by 2, we can break it down to 2x plus 2 when x does not equal 0. So this is our simplified rational expression. When you have something that is factorable on the top and the bottom, your first step is to factor. So this is a difference of squares, so it's going to turn into x plus 7, x minus 7, and on the bottom we have two numbers that add up to negative 5 and multiply to get negative 14. You should use negative 7 and positive 2. And because a is 1, we skip to the last step, x minus 7, x plus 2. Once it is factored, you must find your non-permissible values. So x minus 7 equals 0, so x cannot be a 7. And x plus 2 equals 0, so x cannot be a negative 2. Once you have your non-permissible values, you can simplify your equation, or your expression. Because these are the same, they are going to cancel out. So you're left with an x plus 7 on the top and an x plus 2 on the bottom, when x does not equal 7 or negative 2. When you have two binomials, you cannot simplify any farther than this. For the last example, we're going to factor the top and factor the bottom. So on the top we have two numbers that add up to a -5 and multiply to get a -6, and we should use -5 and -6, and +1. When we factor this, I always do it on the side just to keep my work a little bit more organized. 2x squared minus 6x plus x minus 3. Break it into two groups. Take out a 2x, double x, what am I doing? And take out a 1. So we should have 2x, x minus 3, plus 1, x minus 3. So your final is 2x plus 1 over x minus 3. So we can plug that into our equation. Now on the bottom we have 9 minus x squared. This is a difference of squares, so we can go 3 minus x and 3 plus x. Because these two right here are similar, x minus 3, 3 minus x equals 0. When you solve for them, x is still going to equal +3 for both of them. So they're actually pretty much the same thing. So when we them out, we can actually cancel them out. So first we're going to find our non-permissible values. Always do this before you cancel. So x cannot equal a +3 or a -3. We can cancel these two out. So we should be left with 2x plus 1 over 3 plus x when x does not equal 3 or -3.